Hello students, welcome again. That was the question, a question of complex number. See, the concept of roots of unity is extremely important in the chapter of complex number, of course, along with the geometrical application that we had been continuously seeing with the help of various questions. So this question, as you would have figured out, I strongly believe that those students who would have tried this question, when you would have got this question as a post on the channel, you would have definitely been able to figure out that this is a question based on roots of unity concept. Okay, see how. See, if you remember that for the nth root of unity, whose equation is z raised to the power n is equal to 1. So when we talk about nth roots of unity, you all should remember that we are talking about the roots of this equation. Which equation? Z raised to power n is equal to 1 or x raised to power n is equal to 1. Variable doesn't matter. Okay, so any such equation roots are called roots of unity. Now, if we talk about its roots, generally we represent its roots as 1, alpha, alpha square, alpha cube until alpha raised to the power n minus 1. Isn't that? So this is how we represent the roots of this equation, the roots of unity. Where in general, what do we say? Where in general we say that alpha raised to the power k is nothing but cos of 2k pi by n plus iota times sine of 2k pi by n. Now, I always tell to my students that whenever you come across any such expression in complex number or question related to complex number, the first thing that should strike your mind is the concept of roots of unity and all the properties which are related there. Okay, now you can definitely say that, sir, okay, this is not comparable to that form because it is cos 2k pi by 10. That simply mean if I am going to use the concept of roots of unity, n is 10 here. Okay, but instead of plus iota is minus iota. So of course I will say yes, that's the point. But then I will say, okay, let us write z subscript k as cos of minus 2k pi by 10 plus iota times sine of minus 2k pi by 10. Isn't that? Now, how come does that make a difference? That makes a difference again. Now we will go to the geometrical aspect. See, when we plot the roots of unity on the Argand plane, first root is 1, of course that's 1. Okay, now when we mark alpha, let's say this is alpha here. So how much is this angle? This angle is nothing but 2 pi by n. Then we mark alpha square. This is alpha square and this angle is again 2 pi by n. Overall this angle is 4 pi by n. Okay, now we know that one root, see again, one important thing. This is a real equation, a real polynomial equation, isn't that? So how do we define real polynomial equation? Any polynomial equation whose all the coefficients are real. So there are just two terms and both the terms have real coefficients. So it's a real polynomial equation, and we fundamentally know that in a real polynomial equation, complex roots or imaginary roots exist in conjugate pair. So that's true here also. So the last root, which is alpha raised to the power n minus 1, the last complex root of the root of unity is the conjugate of the first root, which is alpha. The second last root, which is alpha raised to the power n minus 2, is the conjugate of the second complex or imaginary root, which is alpha square. And then again, we know that if this angle is 2 pi by n and we rotate for its conjugate in clockwise direction from the real positive real axis, this angle has to be minus 2 pi by n. Okay, so what I am trying to say here is that if I just reverse my angle here, so instead of taking 2k pi by n, if I take minus 2k pi by n, what's actually happening is that the first complex root will be the last complex root in this form. So the last complex root, when you write it in this form, is alpha raised to the power n minus 1, and as you can figure out from this figure that this is going to be the first complex root. So ultimately what will happen is this is the first complex root, I may call it beta, this will be the second complex root beta square, and so on and so on. This will be beta raised to the power 9 and one root is of course 1. So everything remains same. Everything means, so we know here sum of all the roots of unity 1 plus alpha square dot 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 alpha raised power 9 is 0. So since the alpha raised power 9 is nothing but beta, so you will write 1 plus beta square, which is alpha raised power 8, and alpha is nothing but beta raised power 9. This also remains 0. Okay, so it's like z subscript k represent the roots of the same equation but in the reverse order. So that's why I kept this question as a like for a discussion here on the channel, so that I can discuss so many things. Okay, so first point, we can convert it to the standard form by using the properties of cos and sine. We know cos of minus theta is cos theta, sine of minus theta is minus sine theta. Okay, and then I just wanted to share with you all that this also represents the same set of roots which we get while we consider it as cos theta plus iota sine theta form. Clear? So now, as I wrote here, now you have seen that we are talking about 10 roots of unity. Okay, now again a very important concept, we know if we have roots of the equation, we can write it in factor form, and this is how we write it in factor form. Isn't that bacho? So that means for z raised to the power 10 minus 1, I can write it as z minus 1 into z, the first root, z minus beta, and to z minus, and beta is z1. Okay, so instead of writing beta, so that you don't get confused, I will write z1. Fine enough, bacho? Then this is beta square z2 dot 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 z minus z raised power 9, which is beta raised power 9 here. Okay, now what do we need? We need the product of 1 minus z1, their modulus of course, 1 minus z1, 1 minus z2, 1 minus z3. We can get it directly. We can get it directly when we substitute z is equal to 1. But can we put z is equal to 1 on both the sides? Because that will give us an identity. 0 is equal to 0. So this is also 0, this is also 0. But then see, if you put z is equal to 1, rest of the terms which you get gives us the form which we need. 1 minus z1 into 1 minus z2 into 1 minus z3 dot 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 1 minus z9, and then you take its mod. You will get the answer, if at all we can get the answer. Okay, so now what? I will write it as, so before putting z is equal to 1, before putting here z, substituting z by 1, I will bring z minus 1 from right hand side to the denominator of left hand side, and then we have this form. Okay, now there are two ways of approaching, of simplifying. We already know that we have to put z is equal to 1, and that will give us the required form, but then this is the problem. So there are two approaches. You can solve the limiting value as z approaches 1 using that L hospital rule, and then you can differentiate it using L hospital. You can find a limit, and the limit is nothing but, so let's put the value 1 minus z1 into 1 minus z2 dot 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 1 minus z9. Okay, now put the value of z a limiting value. So this is 10. So 10 is equal to 1 minus z1, 1 minus z2, and dot 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 1 minus z9. Now taking modulus both the side, and we know that modulus gets distributed over the product. So I can write mod of this into mod of this into mod of this, and then you bring this 10 in the denominator, and this is a real number whose mod is 1, the positive real number 1, so its answer should be 1 here. So the answer of this part must be 1 here, bacho. I believe you all would have got it. Okay, as I said, there are two ways of approaching it, at least two ways that I can see here. One is solve evaluation of limit. The other one could be z raised to 10 minus 1 upon z minus 1. This can be seen as a sum of GP whose common ratio is z and number of terms are 9, and the first term is 1. Okay, so you can replace it, this expression, by the sum of 10 terms of a GP whose first term is 1 and the common ratio is z. And now when you substitute z by 1, you will get 1 plus 1 plus 1, how many times? 10 times. So again you will get 10. Okay, so these are two ways in which you can approach it. So that was about the first part. Now let us consider the second part here. See, second part is this. Now as I said, the sum of the sum of all the roots of unity is 0. So what does that mean? That simply mean, if I write them like from k0 to 9, so k0 is 1, so 1 plus beta, which is z1, plus beta square, which is z2 dot 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 beta raised to the power 9 is 0. Now if I start putting the value bachcho, so it will be summation of cos 2k pi by 10, k goes from 1 to 9, plus iota times summation of sine of 2k pi by 10, k goes from 1 to 9. This is 0. Okay, so that's it. Acha, one more thing. If I remove, see, how are we getting k? 1 here. You get 1 when you put k is equal to 0, and in the summation we need k is equal to 0 to 9. So if I replace this 1 from here and then start from k is equal to 0 to 9. Okay, I believe you all would have got it. So this gives you 1 for k is equal to 0, and sine 1, when you put k is equal to 0 here, that won't make any difference because sine of 0 is 0. Okay, now a complex number is equal to 0, that means the real part is 0, the imaginary part is 0, isn't that? So that means this part is nothing but 0, so sum of 1 minus 0 is 1 again. So the answer of both the parts according to me is 1, and that should be the answer. I don't have any doubt in it. Okay, so I believe all of you would have understood the concept, the things which were involved in this question, bachcho.